You know, scientists believe the universe kicked off with a monumental event known as the Big Bang. Right after that, there was this crazy period called inflation, where everything just rapidly expanded. Wrap your head around this: 93 billion light-years across. That's mind-bogglingly huge, right? But here's the kicker. That's only what we can see. Yep, there's potentially an endless expanse beyond our current observation. It's a bit of a puzzle, isn't it? But fear not. We've got some powerful tools at our disposal, like the James Webb Space Telescope and brilliant minds like Roger Penrose to crack open these cosmic enigmas. We're on a journey to push the boundaries of our understanding of this extraordinary universe. Let's dig in. So, picture this. The part of the universe we can see is pretty darn colossal. When we talk about its size, we often refer to what's known as the observable universe. But what exactly does that mean? Well, it's essentially the portion of the cosmos that we can spot from our cozy spot here on Earth. Let me break it down for you. Light travels incredibly fast, right? It's the speed champ of the universe. But even with its blistering pace, light still takes time to zip from one spot to another. Now, consider this. The universe is approximately 13.8 billion years old. So when we gaze at something really distant, what we're actually seeing is light that set off from there eons ago. If something is so far away that its light would take more than 13.8 billion years to reach us, well, tough luck. We won't be able to see it because the universe hasn't been around long enough for that light to make the journey. Our observable universe is like a giant bubble enveloping us, stretching out as far as light could have traveled since the universe sprang into existence. And guess what? That bubble extends roughly 46 billion light-years in every direction from us. Amazing, isn't it? Why does the universe seem larger than its age of 13.8 billion years? Well, it's because the universe has been expanding since its inception. Things that emitted light 13.8 billion years ago have moved farther away due to this expansion. So, we're left with a bubble or sphere around us that spans 93 billion light-years. Pretty mind-boggling, right? And that's just what we can see. There's likely much more out there that's beyond our current view because the light hasn't reached us yet. Within this observable universe of ours, there's a bustling scene. We've identified at least 2 trillion galaxies, each hosting billions or even trillions of stars, along with planets and other celestial objects. But it's not just the visible stuff that's intriguing. There's a whole universe of unseen phenomena, like dark matter, this enigmatic substance that we can't directly observe but know exists because of its gravitational effects on galaxies. Then there's dark energy, which is even more perplexing, propelling the universe to expand at an ever-increasing pace. And let's not forget the faint cosmic microwave background radiation, a lingering echo of the Big Bang. Plus, there are neutrinos zipping around, these elusive particles barely interacting with anything but still making their presence known. Enter the concept of redshift. Since we're confined to observing within our visible universe, we're in the dark about what lies beyond. The universe isn't static, it's in a perpetual state of expansion. This means everything, galaxies, clusters of galaxies, is steadily moving away from each other. Some distant objects may eventually drift beyond our sight. This expansion also alters the light we receive from distant sources, stretching out their wavelengths, a phenomenon known as redshift. The farther something is, the more its light is redshifted. It's like we're watching a cosmic spectacle, but there's a time delay. When we gaze at a star 10 light-years away, we're seeing it as it was a decade ago. By observing objects at varying distances, we can essentially trace the universe's entire history, from its earliest moments to the present day. It's like having a front-row seat to the ultimate cosmic drama, spanning billions of years. Let's take a journey to the Sun and the Moon, shall we? These celestial bodies may seem close, but in reality, they're quite distant from us. Starting with the Sun, it sits a whopping 150 million kilometers away from Earth, give or take. That's roughly 93 million miles. We measure this distance in astronomical units, or AU for short. However, this distance isn't fixed because Earth's orbit around the Sun isn't a perfect circle. It's more of an ellipse, or a slightly stretched out circle. So, when Earth is nearest to the Sun, which typically occurs in early January, we're about 147 million kilometers or 91 million miles away, a point called perihelion. Conversely, during early July, when we're farthest from the Sun, we're about 152 million kilometers or 94 million miles away, termed aphelion. During aphelion, we're at the furthest point in our non-circular orbit, taking us quite a distance from the Sun, which might seem a bit counterintuitive in July. Now, let's shift our focus to our faithful companion, the Moon. The average distance between Earth and the Moon is approximately 384,000 kilometers or 238,000 miles, which is about 0.26 AU. Similar to the Sun, the Moon's distance varies because it orbits Earth in an ellipse. Once a month, the Moon approaches its closest point to us at about 363,000 kilometers or 225,000 miles, known as perigee. Conversely, about once a month, it reaches its farthest point, approximately 405,000 kilometers or 251,000 miles away, called apogee. To grasp the enormity of these distances, let's consider a hypothetical scenario where you could travel at the speed of light. It would take you approximately 8 minutes to reach the Sun from Earth and a lightning-fast 1.3 seconds to reach the Moon. But what if your speed was limited to that of sound? Well, the journey to the Sun would stretch out to about 14 years, while reaching the Moon would take around 10 days. Now, let's venture beyond our immediate celestial neighborhood to our nearest stellar neighbor after the Sun. Enter Proxima Centauri, part of a captivating three-star system known as Alpha Centauri. Unlike our Sun, Proxima Centauri is a red dwarf star, more subdued and laid back. However, in terms of distance, it's approximately 4.25 light-years away from us here on Earth. So, when we talk about a light year, we're basically describing the distance light travels in a year. Picture this. When we peer through our telescope at Proxima Centauri, we're not seeing it as it is right now, but rather as it appeared 4.25 years ago. But here's the kicker. Proxima Centauri has some fascinating features. It's home to planets, and guess what? At least 2 of them exist, with one possibly residing in the perfect zone for life. We call this sweet spot the Goldilocks zone because it's just right, not too hot, not too cold, possibly fostering conditions for liquid water and, who knows, maybe even life. Now, let's shift our gaze to the other stars in the Alpha Centauri system, Alpha Centauri A and Alpha Centauri B. These stellar companions resemble our own Sun in terms of size and brightness. They also have a unique relationship, orbiting each other, with a vast distance of about 23 times the span between Earth and the Sun. From our perspective, they're a tad farther than Proxima Centauri, approximately 4.37 light-years away. But let's put these distances into perspective, especially in terms of travel time. If we could travel at the speed of light, we'd reach Proxima Centauri in 4.25 years. However, if we were limited to the speed of sound, buckle up for an incredibly lengthy journey. We're talking a staggering 77,000 years just to reach Proxima Centauri. Now, let's take a step back and contemplate the grandeur of our galaxy, the Milky Way. Here's a mind-boggling fact. We've never captured a true photograph of the entire Milky Way. What we perceive are either artistic renderings, educated guesses, or images of other galaxies that bear resemblance. The reason? Our galaxy is colossal, spanning about 100,000 light-years across. To snap a selfie of our galaxy, we'd need to dispatch a camera so far into space that it would take longer than the age of the universe just to position it, not to mention the millennia required for the photo to journey back to us. Consider this. Since the dawn of radio technology in the early 1900s, its signals have been spreading throughout the cosmos. Yet, even at the speed of light, these signals have only covered a distance of about 100 light-years. Given the Milky Way's vast expanse of 100,000 light-years, that's merely a fraction. So, as it stands, a whopping 99.99% of the stars in our galaxy remain oblivious to our existence. Despite the Milky Way's immense size, our view of it from Earth is limited to a mere fraction. On a clear, light-free night, if you venture far from the glow of city lights, you might count around 3,000 stars twinkling in the heavens with just your naked eyes. Now let's delve deeper into the wonders of the Milky Way. Picture it as a colossal, pancake-shaped entity spanning between 100,000 to 200,000 light-years across, with a thickness of tens of thousands of light-years, particularly bulging towards its center. Speaking of which, at the heart lies a spherical mass roughly 12,000 light-years wide. Our own Sun sits around 26,000 light-years from this core, nestled within what we dub the Orion Arm. Our Milky Way is a bustling metropolis of stars, boasting anywhere from 100 to 400 billion, each potentially accompanied by its own retinue of planets. At the center of this cosmic cityscape, we find Sagittarius A*, a supermassive black hole emitting powerful radio waves suspected to weigh as much as 4.1 million suns. As for our cosmic neighbors, they're not exactly within arm's reach. The closest major galaxy, Andromeda, lies a staggering 2.5 million light-years away, while others in our local vicinity range from 25,000 to 4.5 million light-years distant. Let's talk about the local group. It's not just the Milky Way cruising solo, it's a bustling community. Over 20 galaxies, including ours, make up this celestial clique sprawling across a distance of about 10 million light-years. Together, the stars in this group accumulate a mind-boggling mass, 2 trillion times that of our Sun. Credit for unveiling the existence of the local group goes to Edwin Hubble, the namesake of the famed Hubble Space Telescope. Back in the day, when space scientists were unraveling the mysteries of distance and velocity, Hubble made a groundbreaking revelation. What we once thought were mere extensions of our Milky Way were, in fact, separate galaxies like Andromeda and Triangulum. Not only did he identify them as distinct entities, but he also uncovered their gravitational dance as they gravitated towards one another like celestial magnets. Indeed, gravity proved to be the invisible force shaping our cosmic neighborhood. So, let's talk about the neighborhood of galaxies we live in. Picture it like this. On one side, there's our home, the Milky Way, surrounded by its gang of smaller satellite galaxies. On the opposite end, there's the Andromeda Galaxy, along with its own crew of satellites. The gap between these two main players stretches about 3 million light-years, and they're closing in on each other at a speed of 123 kilometers per s. Both the Milky Way and Andromeda are big shots around here, each packing about 1 trillion times the mass of our Sun. They've got their entourage of mostly dwarf galaxies tagging along for the ride. And after the Milky Way and Andromeda, we've got the Triangulum Galaxy, or M33, which is a bit smaller but still significant with a mass of around 50 billion times that of our Sun. Now, there's some uncertainty about Triangulum's relationship with Andromeda. They're relatively close in cosmic terms, just 750,000 light-years apart. A few billion years ago, they had a close encounter that led to a burst of star formation in Andromeda. But whether Triangulum is a true companion to Andromeda or just a passing acquaintance is still up for debate. Zooming out a bit, let's talk about the Virgo supercluster, which is like a bustling city of galaxies. It's not just our local group hanging out there. There are over 100 other galaxy groups and clusters too. It's massive, spanning about 110 million light-years across, and it's heavy, with a mass of around 1,480 trillion times the mass of our Sun. But the Virgo supercluster isn't alone in the cosmos. It's part of something even bigger called the Pisces-Tetus supercluster complex, which is like a giant highway of galaxies stretching across the universe. The person who first figured out that the Virgo supercluster was a thing was Gerard de Vaucouleurs in the 1950s. He realized there was this big group of galaxies, including our local group, and he called it the local supergalaxy, later the local supercluster. He built on the work of Edwin Hubble, who also realized that galaxies were moving towards each other due to gravity. De Vaucouleurs used these discoveries to identify the Virgo supercluster. When we contemplate our position in the vast expanse of the cosmos, it goes beyond just our little blue planet or the Milky Way galaxy we call home. We belong to a much larger framework, starting with our local group, then extending to the Virgo supercluster, which is nestled within the Pisces-Cetus supercluster complex, all within the grandeur of the universe itself. This universe is teeming with a myriad of celestial bodies, planets, galaxies, groups, clusters, superclusters, and complexes. Now, the Virgo supercluster isn't merely a random assortment of galaxies. It has a discernible structure. Picture it as a colossal disk with a concentration of bright galaxies at its center, arranged along what astronomers refer to as the supergalactic plane. This plane isn't tangible. It's a conceptual line used by astronomers to chart the distribution of galaxies within the supercluster. Surrounding this central disk is the halo, a more or less spherical region containing galaxies that aren't part of the disk. At the core of this supercluster lies the Virgo cluster, the largest and most massive gathering of galaxies within it, hosting over 1,300 galaxies and weighing roughly 1 quadrillion times the mass of our Sun. Our local group, including our Milky Way, sits on the outskirts of this cosmic metropolis, connected by a string of galaxies stretching from the Fornax cluster to the Virgo cluster. So, why does the Virgo supercluster hold such significance for astronomers? It serves as a window into various astronomical phenomena. It allows them to observe and understand the formation and evolution of galaxies, their interactions, and how they are influenced by their cosmic environment. Moreover, studying the supercluster provides insights into the broader structure of the universe, its expansion, and the enigmatic forces known as dark matter and dark energy. Intriguingly, astronomers have observed the gradual movement of the Virgo supercluster towards an area of space dubbed the Great Attractor, characterized by an unusually strong gravitational pull, affecting not only the Virgo supercluster, but also neighboring superclusters. Adding to the fascination, a study in 2014 revealed that the Virgo supercluster isn't an isolated entity, but part of a larger supercluster named Laniakea, a Hawaiian term meaning immense heaven. Laniakea supercluster is home to our Milky Way and approximately 100,000 other nearby galaxies, stretching an astonishing 520 million light-years across and boasting a staggering mass of 100 quadrillion times that of our Sun. Similar to the Virgo supercluster, Laniakea is nested within the Pisces-Cetus supercluster complex, an expansive thread of galaxies weaving through the cosmos. Laniakea isn't the only supercluster out there in the vast expanse of the universe. In fact, it's a relatively recent addition to our celestial atlas. Back in September 2014, a group of astronomers introduced a new method to define superclusters. They did this by observing how galaxies move in relation to each other. They focused on something called peculiar motion, which measures a galaxy's overall movement while discounting the part caused by the universe's expansion. By tracing the paths galaxies follow and identifying the gravitational centers pulling them together, astronomers could outline the boundaries of superclusters. These gravitational centers act as the driving force behind superclusters, drawing galaxies towards them and shaping their structure. Now let's take a closer look at Laniakea. This supercluster isn't a single uniform entity. It's actually composed of 4 distinct regions. These regions were once considered separate superclusters: Virgo, Hydra, Centaurus, and Pavo Indus Southern. The heart of Laniakea lies near a powerful gravitational focal point known as the Great Attractor. This cosmic hotspot exerts such a strong pull that it's drawing in neighboring superclusters, akin to a gigantic cosmic whirlpool. Our own neighborhood, where the Milky Way resides, isn't at the center of this gravitational dance. We're situated more towards the outskirts of Laniakea, along a slender line of galaxies stretching from the Fornax cluster to the Virgo supercluster. Much like the Virgo supercluster, Laniakea provides astronomers with valuable insights into the larger structure of the universe and its expansion. Additionally, it offers clues about elusive phenomena such as dark matter and dark energy, which remain among the greatest mysteries in modern astronomy. Interestingly, Laniakea itself appears to be in motion. Scientists have observed that it's heading towards an area of space known as the Shapley concentration, another vast supercluster that may be part of an even larger structure called the Shapley supercluster complex. Now, you might be wondering how we gather all this information about the universe's structure. Well, a considerable amount of our knowledge comes from advanced space observatories like the Hubble Space Telescope and the upcoming James Webb Space Telescope, which continue to unveil the secrets of the cosmos. Let's start by delving into the wonders of the Hubble Space Telescope. Since its launch in 1990, Hubble has been our cosmic photographer, capturing breathtaking images and collecting an abundance of valuable data. It's equipped to detect visible light, ultraviolet light, and near-infrared light, making it an incredibly versatile tool for astronomers. Positioned about 547 kilometers above Earth, Hubble boasts a colossal main mirror spanning 2.4 meters in diameter. Now, let's turn our attention to the James Webb Space Telescope, JWST, which could offer a helping hand in solving a cosmological conundrum we're currently grappling with. This puzzle revolves around understanding the size and rate of expansion of the universe, particularly concerning something known as the Hubble constant. Presently, different measurement methods yield conflicting results. JWST has the potential to reconcile these disparities by providing more precise measurements of the Hubble constant using various approaches. For instance, it could observe standard candles, such as specific types of stars, supernovae, or quasars whose intrinsic brightness we can determine. By observing them in infrared light, JWST can bypass the interference caused by space dust, enabling more accurate distance calculations. Moreover, JWST could utilize gravitational lensing, a phenomenon where light from distant objects bends as it passes near massive celestial bodies like galaxies. This bending can produce distorted or multiple images of the same object, which JWST can exploit to calculate distances, thus refining our grasp of the Hubble constant. Additionally, JWST could employ cosmic chronometers to gauge the universe's expansion. These are objects like ancient stars or galaxies whose ages we can estimate by analyzing their emitted light. By correlating their age with their observed redshift, JWST can provide insights into the Hubble constant. In essence, JWST has the potential to enhance our comprehension of the universe's dimensions and evolution significantly. It might even offer glimpses into the history of previous cosmic cycles. Do you ponder whether the universe is infinite? Share your musings in the comments below. Stay tuned for more captivating videos that will challenge your understanding of the cosmos.